Good morning, everybody. How you doing? This is Mr. James right here. I say welcome back to school to you guys in SS2. How you guys doing? I hope you've been well. I hope the holiday has been good on you. I hope your family has been very fine. I hope you've been helping out with work, with chores, at home. I hope you've been reading your notebooks as well. I hope you've been reading your books. Very important. Very, very important. It's a very important case, and basically, I'd like to welcome you guys to today's math class. I promised I was gonna, I was gonna keep tabs on you guys. For today's class, it is important that you guys have your notebooks and your pen with you. If you've not written the notes that has been sent to you, this is an opportunity for you to do that now. So this is I'm going to be using the same note I sent to you, and that's the same note I'm going to be working on with you guys. All right. So moving on. First thing I want to tell you guys. I realize that there are some of you who probably might have started preparing towards WAEC for next year. It's important that as you prepare yourselves, I'm interested in helping you out. So you see this link on your screen now. You see this link on your screen. This one. I'd like you to copy it after or you can write it down right now. You can write it down, and then maybe when you're done with the class, you can go online. You can open your browser, preferably Google Chrome. You type in this link, right? And then when you type in the link, probably I'll just include it in the description below. So when you enter the link, you just takes you to Google Play Store for you to download a particular application, and it's a CBT application for WAEC and JAM questions in WAEC, questions in JAM. You can get access to them, solve questions, answer questions, find answers to questions as well. Do you see now? So it's I believe it's going to help you guys out in your preparation towards the WAEC examination that might be coming up next year, of which with this lockdown now, we are not sure, but it may seem that this year's WAEC might be moved to next year. So whichever the case may be, you can start preparing yourself for whenever it is going to come. Do you get now? So it will be nice for you to download the app. So copy the link to your browser, preferably Google Chrome, and then download it. Enter, and then it leads you to the Play Store, and then you can download it. All right, so let's move on. Today I'm going to be teaching you guys something very important in mathematics, and it's called the tangents from an external point. Now, I believe that you guys have been doing a lot of circle geometry. You've done a lot of circle geometry in probably your SS1 class, and then maybe in this SS2, but there are also some other features of the geometry of circles that we'll be looking into today, and that's the tangent. Now, the first theorem we are going to be looking at is the tangent of a circle from an external point are equal. That is, the tangents, remember, it's with an S. You see now there is an S there. So the tangents to a circle, that is the what the tangent is, right? The tangent is the line that is drawn outside a circle now, and it touches the side of the circle. Do you see now? That's the tangent, and then it is usually perpendicular to the center of the circle. When you draw a line from the center of the circle to the tangent, that line that touches the circle, when you draw the another line from the center of the circle to that body of that part of the circle that it touches. When you draw a radius from the center to the body of the circle, and it meets with the tangent, it forms a perpendicular shape. And you know what the perpendicular shape means? It means what? Angle 90 degrees, right? Good. Now, so look at this now. Given a point T outside a circle, now look at this now. This is the point T, right? It is outside the circle. And then the circle, the center of the circle is labeled what? O. Do you see that here? It's labeled O. Now, TA, that is the line from the tangent from point T to A, right? And TB, that is the tangent from point T to B, are tangents to the circle at A, that is at this point, and at this point. Do you see that now? That is at A and B. Now, what we want to do is we want to prove that line TA, that is this line, is equal to this line. Do you see that now? Let me clear the screen a little bit. Now, we want to prove that this line and this line are equal. Now, these are the things that form the basis of our calculations of our solving of problems with questions that involve tangents to circles. Do you get now? So let's move on and see now. When you do in the construction, you find that, okay, now this is an explanation of how to construct it. You draw your circle, and then you draw the line. When after drawing the circle, from point T, you draw the line to form a tangent on the circle here called A, and then you draw another line to form a tangent on the circle called B, right? So now it now says draw a line from center O to A and another line from center O to B. That is what we see here. Join OA and OB. That is, draw a line from that center to A and draw another one to B. Do you see that now? So that's just like that. So then it now says in triangles OAT, that is from O to A to point T, you can see that there is an imaginary line in the center. That line is what we call a it's just a joining point. Do you get that? It's a line that joins the center of the circle to the T. Do you see that now? Do you get it now? So now, when you draw this imaginary line to T, right, then it's now saying that this allows this whole thing here to look like two triangles. If you take a look at it properly, you see that it forms two triangles, one that looks like this and one that looks like this. Do you see this now? Forms two triangles. So the both of them end at T. The first one is start at O. Point O, the same point O. On this side we have A, on this side we have B. Do you see that now? So this triangle is triangle what? Triangle OAT, right? And then this triangle is triangle what? OBT or OTB, whatever the case may be. Do you get now? But more importantly, it would be nice that you arrange it in alphabetical order, saying A O T and B O T. But regardless, let's continue with the work. Now look at this. We have OAT. right? We have OAT. The first, there are two triangles that are formed because of that imaginary line in the middle. Do you see that now? So we have O here, we have A here, we have T. This is our T. This is our O, center, right? And this is our B. So he's now saying triangle OAT, this one, and this one have been formed. Do you see now? We have formed those two triangles, triangles OAT and triangles OBT. Now, you see that based on this, you see OAT, that is triangle OAT, this one, and triangle OBT are equal to 90 degrees. Both of them are equal, they are the same, and they are both 90 degrees. What does this mean? The angle at O angle at point A and O angle at point B is what equal to 90 degrees. That is, this is a perpendicular line. Remember, I told you it forms a perpendicular line when joined to the center of the circle. You see now, you know that what is a radius now? A radius is a line from the center of a circle that touches any part of the circle, any side of the circle. You see now, so the line that comes from the center of the circle has touched point B. You see now, and point B is a tangent to the circle. Now that makes that angle formed at B, the angle that is formed at B, to be 90 degrees. The same thing occurs with angle formed at A when drawn from the center of the circle to the tangent A. Do you see now? It makes a perpendicular angle to be formed, which is equal to what? 90 degrees. That is why here you see that it is indicated here that it's from the radius to the tangent. Do you get it now? So now, taking a look at this, let me clear this screen so we can have enough space to work. All right, now you see, looking at line OA. Now this line here, that's from point O to A, and line OB. Do you see that now? They are both radii. You get now? Radii is the singular form of radius. Radius is the plural form. You see now? Line OA, that's from O to A, in that diagram you see, is a radii, right? And then line O to B, the line that is drawn from O to B, is also another radii. Do you see now? So that is what we want to, that's what we are confirming. These are some of the things that will help us to prove this question right or wrong, this statement rather, that the two triangles are equal. Now moving on, since, look at this now, it has been stated in that this side of the triangle, the triangle is like this. There are two triangles. The second one is like this, right? So they said this side and this side is already equal. Do you see that now? This side and this side is also equal. So is it possible for this line that is already actually what's it called, the line that joins them together, that is actually the line, this line, it does not change from O to T. That is the only line that remains the same. Do you see now? So both of them are sharing that line, so they are using the same line. That is why you see that OT for the first triangle, OT here for the first triangle is still the same thing as line OT for the second triangle, which is what? A common side for them. Do you see that now? Which is what? A common side for them. Do you get it now? I believe we've been able to establish the fact that these two triangles form a particular perpendicular angle because of the line drawn from the center of the circle to form a radius, to form the radius for the two sides. Do you see that now? Touching the tangents A and tangent B, and then it forms a perpendicular angle which is equal to 90 degrees. Do you see that now? The same thing now for this one. Both of them are radii. They are both individually a radii. That's the line drawn from O to A and the line drawn from O to B. Do you see that now? In this diagram, from O to A, from O to B, they are radius. Good. Now and then line OT is the common side between them. Now look at this. Therefore, the triangle OAT is equal to OBT. Why? Because all their parameters are the same. From the base of the triangle to the height of the triangle to the hypotenuse of the triangle, all is the same. From the base of the triangle to the height of the triangle to the hypotenuse of the triangle, all is the same between the two of them. That is why we can then say that the two triangles are equal. Therefore, your line from T to A and from point C to B, they are also what? Equal. Now, it now says that, note this thing, that the angle AOT, that is the angle at O, is also the same for the angle at O for triangle AOT. Do you see that now? This angle is what we are talking about. That's angle AOT is still equal to this angle as well. They are both the same. The sum of them is their sum is the same. That is from O to B. Now that's BOT, right? OBT or BOT, whatever. That is B angle at OT is the same as A angle at OT. Do you see that now? Both of them are the same. They are what? The same. So if the total angle here is, for example, maybe is 80 now, and they said one of them is 40 degrees, and then the other one is X, and they say find X, definitely you know that since this angle and this angle are the same, you definitely know that X2 will be what? 40. Or you say 40 subtracted from 80 to still give you the same 40. Do you see that now? That's very important to remember, that the angle at that center of the circle, you see, that is formed at the center of the circle when joining those two tangents to the center of the circle, the angle formed is an equal division between the two triangles. Do you see now? The angle here is equal to the angle here. Do you get it now? So that is very important to take note of. And then this means that when you look at the angle formed at T, also the angle formed at T at the what's it called? Let me clear the screen so that we can have a place to. That means that you see this small angle here is the same as this angle formed at T here also. Do you see that now? That is for the triangles, for the two triangles, for your point T also, the two angles are joined together equally. They are both equal. That is, this angle equals to this angle. Do you see that now? So when you have, let's say you have 40 here, both of them will be 20. Do you get now? If the total angle is 60, this one will be 30, this one will be 30. Do you get it now? At point T, the angle at point T is equal for both the first triangle and the second triangle. Do you get it now? Hence, the line joining the external point to the center of the circle bisects the angle between the tangent and the angle between the radii drawn to the points of contact of the tangent. What does this mean? This means that you see that line that is in the middle here, this imaginary line that is in the middle here, is what that's the only thing that equally divides the angle at this point T and the angle at this point O. That's what makes the two of them equal. Do you see that now? Because of that middle line that is drawn, both sides are what? Equal. Do you get it now? So that is the basic thing that is important for us to know. Moving on, look at this first example that we have here now. The question says, in the figure below, the center O is the center of the circle, right? And and the and TA and TB are tangents, are tangents, right? That is, line TA and line TB are tangents of this circle that is drawn here. So it now said, if the angle at T, that is ATO, now for the first triangle ATO, you see, you know that there are two triangles formed here, definitely because of the middle line that is drawn, this middle line. So you have something like this, you have a triangle like this. Remember that this one forms what? This one forms a perpendicular angle, right? Is that not so? And then this is our T, this is our O, this is our A, right? The second triangle also is formed using the same method. This is our T, this is our B, this is our point O, right? Do you get it now? So that is it's very simple. So now it now says that calculate the angle T at BX. You can see that this representation here is what we want to find out, that what is this angle. Now if you take a look at it now, you find out that, let me clear the screen so that we can have something. I believe you guys are writing as I've been explaining. So if you've not written anything, if there's something, a point that you missed out, you can rewind and write again. Do you get it now? So now you can see that between tangent A and tangent B, there is a line drawn here. It is a very important line for you to take note of. So it is going to be useful in the solution that we're going to be solving now. Look at this now. This is the first part of the solution. Now you will find that in the first triangle TAX that is formed, that is this one. Now this is our point X here. Do you get it now? So now the first triangle let me clear that. That's TAX. Now you see that we did not cover this part. You see that we did not cover that side, right? We only covered from A to X. Now we are not taking O. Now we want to, because the question says what is TBX, that is TBX. This is our point X. If you remember, this is our point X, right? And our point O is behind it. So looking into that, we move on and say that in the triangle TAX, that is the one that is up. Good. Now it now says that AX, that is this point from A to X, is equal to 90 degrees. That is this is it. Sorry. Good. Let me draw it now. This is our point X, this is our that point O, and this is our T, right? Good. Now you see that in this triangle there is another triangle formed that is like this, bam bam bam, right? You can see that, which makes another perpendicular angle formed. Now do you see that the angle AXT, that is the angle at X here, as indicated here, is equal to what? 90 degrees. That is an angle at symmetry. Do you see that now? That is another theorem that you should take note of, that the angle at symmetry is what? Is 90. How is it formed? When the angle is, when your line is drawn from tangent A to tangent B and it cuts across that center line, that intersecting line that splits the point T into two triangles. When it crosses it, it forms an angle of 90 degrees. Now take a look at this now. The total sum of angles in the triangle is definitely what? 90 degrees. And remember, in the question we were given, let me go back to the question. This one is going to clear off now. You see, in the question here, our angle T to A to X, right? You see that this side was indicated to be 39 degrees, as you see here. Do you get it now? So now we know that we have something like this, which we are solving with. This is our T, this is our A, this is our X, right? And then our O is somewhere like this, right? Good. Now so we are dealing with 39 degrees, right? This is a right angle here. All we just need to do is know what this angle is. And what is that angle? Sum of angles in the triangle. That is, you add this 90 degrees with 39 and subtract the total answer from 180. Why? Because the total sum of angles in a triangle equals to 180. Is that okay? Good. So 90 plus 39 will give us 129, right? And when you subtract that from 180, you have 51 degrees. Is that okay now? Remember to always indicate the unit of measurement, and that's in degrees, right? So now the angle TBX will also be equal to 51 degrees. What does this mean? This means that you know that we've done for the one here, A, and we always know that both triangles are always the same. They are always what? The same thing. So when we have this, do you see that now? And then we have our point O here. This is our point X. This is our point B on the circle. This is our tangent. You know, for the A, this side is 39, abi? And remember that both angles are the same thing, because it's this line in the middle that separates them into two equal parts, two equal halves. So that means this side also will be what? 39 degrees. Do you see that now? Just as we can see here, that A angle at TO and B angle at TO are also what? 39 degrees. Do you see that? And line AT, that's from T to A, is the same as the line from B to T or T to B, whichever the case may be. Do you see that now? So now they are both the same. So that means that this angle also will be the same as this angle, which is 39 degrees. And then, you know, based on the symmetry formed, this place is also a right angle rather, as it is formed in this place. Do you see that in this place? That was a perpendicular angle formed, which is 90. Another perpendicular angle is formed here as well, which is also 90 degrees. So 39 plus 90 will still give you 129, and then subtract it from that, you still have what? 51 degrees. Do you get it now? So that is how this is established. You see how we are proving all these things by simple basic what's it called now, theorems in mathematics, in your geometry, that is very common to you guys. I believe you understand these things. So moving on from here, you find that the well, we are still solving though. You know, we are trying to find one very important thing, TBX, that is the angle at B, this total angle. You know, we've only gotten this half angle. It remains this remaining side. Do you see that now? We have something like this, we have something like this, we have something like this, and then something like this. Then there's a line in the middle here. Sorry, my hand is not straight too. So this one is 39. This one is also 39. Do you see that now? Their sum will be what now? That will be 70 something. 78 degrees. Do you see that now? Then there is a line of symmetry drawn here that cuts across, that touches A and B, right? This is our point O, and this is our point X. That is the place that cuts through the center line. That's our X. That's the place where the symmetry is started from. So Now we already know that this side will be what, 51 degrees, abi. So the same thing here, this side also will be what, 51 degrees, right? So we now want to know what is this side, this total side, the whole angle at B. That's what we are talking about here. Do you see that now? So okay, we already got the answer, Seth. We already got the answer. That's true. Yeah, sorry. This was supposed to further explain the whole thing for you. These are, you notice that there are three methods by which we have solved this now. The first method is using this method. Do you see that now? Indicating all those various important parameters, and then using this one also. This is another method that you can use to solve. Where time you, this is the beginning point, and then you continue to it, which continues to this place. So that 39 times 2, something like this, half of it is 39, the other half will also be what, 39. So the two of them together gives us what, 78 degrees here. Do you see that now? So let's assume that this is a full triangle. Now we notice that this looks like an isosceles triangle. Two sides are equal. Remember that T to A is the same as T to B. Do you see now? This line is equal to this line. And what is an isosceles triangle? An isosceles triangle is a triangle that two sides are equal and two base angles are equal. That is, this angle and this angle are both equal. So if this place is 78, that means you subtract this 78 degrees from the total number of angles in the triangle, which is what, 180, and then you divide it into 2 for the two of them to share. It's as simple as that. So when you subtract 78 from when you subtract 78 from 180 degrees, which is the sum of angles in the triangle, you get 102, and then you divide it into 2 for the two angles to share. So you have what, 51 degrees. Therefore our angle T at the T angle at B to X, do you see that now, to X is what, 51 degrees. And then if you want to complete it, so T angle at BO will now be what, you know that this complete space itself is supposed to be equal to 90 degrees. So when you subtract 51 from 90 degrees, what do you get? You get what, 39 degrees. Do you see that now? That tells you that this angle is equal to these small angles here. Do you get it now? So I believe this is very simple for you guys. Moving on to the next question that we have here. Look at this question. It says PQR. Look at P, Q, and R. Hey, this is very, very sweet question. Now, these are 3 points on this circle, right? There are 3 different points that touches the circle. Now, the center of the circle, as usual, O. Now, the tangents, the tangents on this circle are points P, right, and points Q, right? Those are the tangents on the circle. Now it says when they meet at this point T here, right? They meet at that point T. Now if PTQ is, if angle PTQ is 62 degrees, that is PTQ, that is the angle at T is what, 62 degrees. Now, right, calculate the angle at R, that is PRQ. Do you see that now? That is, let me clear the screen, sorry. That is, we want to find this angle PRQ, this angle, and this angle. Simple. Naturally, sum of angles at a point is equal to what, 360, right? But what is this angle? What is this angle? That is what we want to calculate, and it's very simple actually. It's in fact one of the simplest questions that you can ever meet in circle geometry, and that's what I would like you to take a look at. We'll be looking at that right now. look at this now. When you join points O and P, right? These are the construction process. That's the construction process. Join O to P, the tangents. Remember, as usual, you should join the tangent to the center of the circle. The same thing, join O to Q as well. So what do you have now? The quadrilateral. Look at this. This is actually a quadrilateral that I want you guys to look at. You see this point T. You have TP RQ or TP OQ. These are four sides. It's formed like this. It's shaped like a kite. If you take a look at it, you find that it is something like this. Let me see if I can draw it now. Yes, something like this, something like this, and something like this. Do you see that now? It has four sides. So this is a quadrilateral, right? Quad. And then right. That center line is there. There's something like this. And then there's something like this. All these ones are just imaginary lines drawn inside it. Do you see that now? Do you see now? So, which also forms something like this. Bam, 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 bam. Abi? If you can see it well, you see it form something like that. Good. Now, take a look at this now. Then, we then select OQT, that is the angle at O, at Q. O angle at Q, that is this angle to this place. So this angle here, this angle is the same as this angle. Do you all know? That is the truth. Because why? This line is the same as this line, starting from that. Then the length from here to here is the same as the length from this O to Q. Do you know that? Therefore, the angle formed here is equal to the angle formed here. Sorry, is equal to the angle formed here. Do you get it now? That is why we have O angle at QT equals to O angle at PT. Make sure that you have the diagram on your notebook so that you can be making a reference to it, because I'll be going back and forth to the image and trying to solve it like that. So so that you can remember where it is represented in your notebook. Now they are both equal to what? 90. Remember I told you that the radius, when the radius, a line is drawn from the radius, that is from this when the radius is drawn from the center of the circle to the body of the circle and it touches the tangent, the angle formed is always what? Perpendicular, which is what? 90 degrees. Do you see that now? So now that is why we are able to determine that this angle here is 90 degrees. The angle formed is perpendicular, and this angle formed is also perpendicular, which is what? 90 degrees each. Do you get it now? That makes it that is what makes the both of them equal. That is, O angle at PT is the same as O angle at QT. Do you see that now? This is our T, right? Good. Now, so moving on, then we are talking about a quadrilateral. Sum of angles in a quadrilateral. Now remember, quadrilateral is equal to 360. So now in this question, we know this side to be a perpendicular angle, which is 90 degrees. We know this side to be 90 degrees, right? That means we do not know what this angle at point O is. So we want to find out what the angle at point point R is, or point O. Point O, point R is all the same. Point O, this point here, we don't know what this angle is. That's what we use to know the angle at this point, and then the angle at this point. Do you see now? So we know this place to be 90, this place is 90 degrees, this place is 62 degrees. So let's add them together and subtract it from 360, which is the sum of angles in a what? Quadrilateral. That is the theorem that is used to formulate this formula that you are seeing here. That is for POQ. That is this angle here, P angle at OQ. Do you see that now? This angle. That's what we are solving for. And then when you add this, you get, when you add these ones, you get 242. And then when you subtract 242 from 360 degrees, you have what? 118 degrees. And then that is, this angle here is equal to what? 118 degrees, 118 degrees. Do you see that now? That is an obtuse angle. Good. So now there is another theorem that says that the angle at a circumference, the angle that is formed at the circumference is what? Is always 2 times, when you multiply it by 2 rather, it gives you the angle at center. Or you can say that the angle at center is 2 times the angle formed at circumference. That is, the angle at this center of the circle, that is formed at the center of the circle, is always 2 times the angle formed at the circumference here. So what does that mean? It means that 2 times angle here at R will give you, not the whole angle at R, 2 times this angle at R that is formed will give you this angle. And when you divide this angle by 2, you will get this angle. Do you get it now? That is the case. So that is why we have this as a solution. That is, you divide the angle at point O by 2 to get the angle at point R. That is PRQ. PRQ. That is this angle. So it still remains another second PRQ again, which is this angle. Do you see that now? So what is the way to solve that? It's also a cyclic quadratic, right? As quadrilateral rather, as we have indicated here. So it's a cyclic quadrilateral. So now R plus R1, or as you can say, the what's it called now? The angles that are formed on a a cyclic quadrilateral. Now look at this now. It says opposite angles of a quadrilateral, or if a cyclic quadrilateral is always equal to what? 180 degrees. Do you see that now? The sum of the opposite angles, that is to say that this angle and this angle are both equal to 180 degrees. That is, if you add the normal R, if you can see in the question here, in this diagram, you see that this thing is indicated as R1, this place here, plus R1 equals to what? 180 degrees. And the rule that governs that is the rule that is stated that opposite angles of a cyclic quadrilateral rather are always equal to what? 180 degrees. So now, what is our R prime, as we might call it? Our R prime, as we might call it now. Our R prime is now going to be 180 minus the answer we got for our angle at R. And what is our angle at R? 59 degrees. So when you subtract 59 degrees from 180 degrees, you have what? 121 degrees. So we can say that the P angle at RQ, the angle at R can either be this guy or this guy. And that is why we have 59 degrees or 21 degrees. Is that simple? I believe it is simple. All right, so that is the explanation for you guys. This is a class exercise for you. A, B, and C are 3 points on the circle, right? Now, on the circle with center O, such that the angle BAC, right, that's the angle formed at this place, is 37 degrees. The tangents at B and C, point B and point C, meet here at T, right? Now calculate B angle at TC, that is, calculate this angle. is a very simple question. I believe you can solve it using some of the examples that you've been taught right now today. I believe you'll be able to solve it. And then this is another question that I would like you guys to take a look at. AB is a chord, right? And O is the center. AB, look at this now. It's a chord, and then O is the center, right? Of the circle. Now it says if AOB is 78 degrees, that is A angle at OB, that is this angle, if it is what, 78 degrees, calculate the obtuse angle between AB and the tangent B. This obtuse angle here. Do you see that now? Do you see it now? It says calculate this total, okay, the total angle that is here. Do you get it now? This is a simple question, very simple. I believe you will understand it properly. It is a very, very, very simple question. Okay, so very simple. It's very simple to understand. There is no need to be worried about how to solve it. It's a simple question. Sincerely, it is a simple question. It's a very simple question. You know what to do. It is a simple question. So solve it, and then I believe you get it right. All right. You have two more questions for today. The dimension of a cuboid metal is 24 centimeters and by 21 centimeters by 10 centimeters. That's the dimension of the cuboid metal. Now, if the cuboid is melted and used in making a cylinder whose radius is 15 centimeters, find the height of the cylinder. You know what to do. All right, and then question 4, the volume of a cylinder is 3600 centimeters cube. Now, and its radius is 10 centimeters. Calculate its curved surface area and then its total surface area. These are questions from your previous topics which you've done in class. All right, so your reading exercise for today, I would like you guys to go to your textbook, your essential mathematics textbook, and page 149, from page 149 to 151, and numbers 11 to 20. Those are questions I would like you to just practice on your own, you see. So then this is your weekend exercise. After you submit those classwork that I gave to you today, make sure you submit it today. Then these questions are these weekend exercises are the ones that you take home over the weekend. Well, you're already at home, but you take it and then you solve it over the weekend. You have the whole weekend to solve it, to think about it properly before you solve, and then get your correct answers, you see. So these are the questions. This set is a multiple choice set. Is a set of multiple choice questions, 1 to 5. You use the diagram here. You see this diagram, you use it to answer those questions below, right? So that is that. And then the theory part is this one. There's a theory question. You have to draw the diagram that tells the story of what you want to do, what you want to solve in these two questions, in the question 1 and question 2. Is that okay? And then you solve it. It's very simple. It's a very simple solution. I just need you to solve and then solve it excellently. All right. Thank you very much for your time. You're good children. I'll see you next time. All right. Good night. God bless you.